Hey everyone, how are you? Alex Williams here of the New Stack, here for another episode of the New Stack Makers. We're doing a live stream today. We are getting a demo of GitOps with the Weaveworks team, and I would like to introduce the folks we have here right now, and we can then give a short overview of what GitOps is. Then we're going to go into a demo. So why doesn't everyone say hello and tell us who you are, and we'll get going.
Hi, Alex. It's Alexis Richardson here. We've spoken before. I'm a co-founder and CEO of Weaveworks and also the chair of the CNCF Technical Committee.
Excellent. Hey, Alexis, how are you?
Hey.
My name is Brian Borum. I am Director of Engineering at Weaveworks.
Hi, I'm Stuart Williams. I am Product Manager at Weaveworks.
Excellent. So I'd like to start by asking you for a quick overview about GitOps. What led you to developing these interesting set of tools that you have? I've been reading more about the diff tools, the architectural decisions that you made, and how it applies to operations. So why don't we get started and with a brief explanation, and then we can go from there.
Hey, Alex, let me go first, and I think then I'll try and hand over to Brian from the engineering team to talk a bit about it from a technical point of view. So GitOps is an iteration of DevOps as applied to the world of cloud native, in particular Kubernetes, which has a strong emphasis on declarative infrastructure. We got excited about it when we discovered that we were capturing a lot more of our system. We run a SaaS called Weave Cloud, capturing a lot more of that system than is typical in Git as YAML files and other configurations. Also, not just that, but also our infrastructure, Terraform, Ansible, which we're using to deploy Kubernetes. Our Grafana dashboards were being stored as code. And we started to think this actually might be quite useful to people when we discovered that we could recover from very large disasters in a very short time, just in a matter of minutes, actually, when we had a complete system outage once, and decided that this is something we should evangelize a little bit more. And we're not saying that necessarily we've discovered anything particularly new. I just think this is kind of best practice for how to do DevOps and configuration as code in an era of Kubernetes. And the principal benefit that we're seeing for customers now that we're introducing some of our ideas into the product is they get much higher velocity in application delivery. So we're seeing people who are getting 2 or 3 times improvements in developer productivity, largely by moving to much more frequent deployments. And GitOps says, do everything through Git. Don't use kube control, for example. And that's something that Kelsey talked about in Austin. There's a video about that on the web. Don't interact directly with the system. Do everything through Git, including all of these social implications of that. You have an audit trail and discussions of changes, even for minor production changes and tweaks in configuration. And if you have a fast enough cycle, you can actually use this to experiment with new features. You can do A/B testing this way, called continuous experimentation. And so we're seeing people go from a couple of deployments a week just using CI systems to 30 or 50 deployments a day, even with very small teams, and as a result, fix bugs twice as fast, respond to customer issues twice as fast. And so we think this is kind of exciting, maybe not completely novel, but certainly something that people should be doing and should be aware of. And I want to emphasize it's a pretty strong view. Really, you should not use kube control at all. Everything if possible should be done through Git. And you should have a complete description of your system state that is declarative if you can, and that is your desired state. And finally, you should observe the system at all times. And if your observed state and your desired state differ, you should be alerted of it, or your orchestration tools, which might be Kubernetes, but also your deployment tool, should drive convergence themselves using things like Kubernetes operations, which is a little bit technical, but it's basically a way of saying we're doing a lot more automation as well in terms of driving convergence between the observed and desired state. So it's a fairly strict view of what operations actually mean. basically operations and configuration are the same thing, and you need to declare all the things, and you need to orchestrate to drive to converged state.
That's one thing that I find interesting about this is your focus on making it declarative, right? And I think that really speaks to a lot of the changes that we've seen with cloud native technologies. This emphasis on declarative environments, as opposed to providing the instructions, which really speaks to more of a machine-oriented approach.
Yeah, if it's declarative, you can also compare it with the observed state much more rigorously.
Right. And does that then become the basis for your diff tools then, in essence, then, to some extent?
Right. So we have, like everybody else, we're GitOps compliant. We fire our diff alerts into our Slack, and various tools tell us when something is different from the desired state in Git, and they fire informative error messages into Slack and alerts saying, this is what seems to be wrong, this is what it's the likely effect of it, and here are links to click on to go find out more and do something about it, which we're finding to be a useful tool. And I know, again, something that other people do, so please don't shout at us for claiming any kind of novelty here.
No shouting. So can we discuss the architecture that you developed here? Because I know you have you've divided it according to, for example, infrastructure. And I'm wondering if you could help us understand kind of the concepts behind GitOps in terms of its architecture.
I would love Brian to step in here because I should not describe such things.
Okay. Let me see. I have on my screen here a little diagram. Is that coming through?
Let me see it here. Yeah.
This way, coming through. Okay. So the key portions of the GitOps pipeline starts with Git. Git is the one source of truth for all of our configuration, declarative configuration. That can be a Git repo for the code, and maybe a different Git repo, or maybe the same one for your operational configuration. And then, so you might have a CI pipeline for the code. That's very standard. But then an automated component which is just syncing that up to your running cluster. So we tend to focus on Kubernetes. That would be your orchestrator, and you just basically continuously running a comparison, checking that the running configured system is configured the same way that Git says it should, and if there are updates that come into Git through your development, review, authorization process, come into the Git repo, which is the one source of truth, they will get synced up to the running cluster. Okay.
Tell us about how the layering approach that you're taking here.
Okay. Let me think.
Starting with the infrastructure and how, because I know you're using other tools in this process.
So that's kind of not on this picture, but basically at the moment, Kubernetes, to take an example, can configure containers and services running on those containers. Kubernetes cannot configure your hosts, your virtual machines.
Right.
So you could use something like Terraform to set up cloud hosts. And then you may also want to install some standard packages, or indeed install Kubernetes itself on those hosts. You could do that with by creating an image and cloning the image, or you might want to do some extra config with something like Ansible. So that would be a layered approach where the sort of machine layer is handled by Terraform, the package install handled by Ansible, and the service orchestration and configuration handled by Kubernetes. Is that what you're getting at? With
Yeah, I think so. I'm just trying to get to kind of the base, help kind of.
Unfortunately, that's a little complicated. I mean, there is work underway in Kubernetes to see if we can get to a declarative definition of more of your machine estate within the one sphere. So I wouldn't kind of depend on that. That's
Right.
sort of where we are.
Right. I think part of my interest is in the plumbing underneath it, and and how it's actually working. But we can.
Yeah, well, I could show you a piece of it working if that's
Okay.
useful. I've got a little service running here, just a web service. Just says hello. I can run that service. It's running in the Google Cloud. And it's running under Kubernetes.
Okay.
And I have in this tab. So this is part of my Kubernetes config for that service.
Okay.
And you don't have to understand really what's on the screen, but I just want to demonstrate. I could take the port number that service is listening on, make a change in the config, and push that through. So that's updated my Git. Maybe I would have maybe I should do that with a PR and have someone review it and say, yeah, we think that's a good idea. It's probably not a great idea in the real world. We're changing the port number, but it's kind of useful for the purpose of demonstrating it. I can then this is part of our Weave Cloud user interface. If I flip over to the deployment screen and just take a look at my so there's a list of all the changes that have gone through from my Git repo on that service in the last little while. Of course, this being a live demo, it's taking its own
sweet time.
Update.
Yeah.
You just refresh that and see if it's okay. No, never mind. Well, so that what I wanted it to do was update the port number. It didn't do that. Another example. I've got a list of all the different images I've built from my source code, let's just see this thing. Oh, okay, it's changed now. It's no longer listening on port 30,001 because I changed. Sorry, 30,002.
Yeah, now it's on one, right?
Let's just see if it's on one. Yeah, there it is.
There it is.
So that part of my demo works. I changed the port number. You may notice it's running a little slowly there, and just to show you, I can update the software as well. So that was a config change. I've got a new release of the software which runs a bit faster. Again, you don't have to understand all the different things that the screen is showing you, but just this idea that we can from our CI pipeline we can see the new images coming through. That one went a lot faster, which is cool. The CI pipeline gives me a new image every time I change the source code, which I did a little earlier. The change in the image feeds through to the cluster, and let's just see if that's running any better. It's hard to tell, but anyway, yeah, I think it's running a little faster. So that was what I hoped to demonstrate there.
Great. Well, so that helps. Do you want to go back to the original image that you were showing again? And now what we were looking at originally is this pipeline for automating releases and syncing with Git. So then so with this kind of in context now, can you take us through this again just quickly to help explain to people what we're looking at?
Yeah, so in terms of those the steps of the demo I just flashed through really
Yeah.
quickly, the config for my cluster is in a Git repo. And so that at the configuration level, I can change things like I change the port number, I can change things like the number of replicas, I can change limits on CPU and memory usage. That's the kind of typical sort of ops domain configuration. And we've got that all in a Git repo, which I can make a change. I mean, I made the change directly in the GitHub UI on a web page, but this could be a much bigger process with reviews and sign-offs and things. But the minute it hit the Git as our single source of truth, the technology underneath, which is our open source project, Flux, synced it up to my Kubernetes cluster. Is that clear enough at that point?
Okay, yeah. So let's run through this quickly. So if there's any changes, right? Well, we'll see the changes here, and then it deploys. It goes through this deploy synchronizer. Maybe you could help us understand the deploy synchronizer.
Yeah. So at a simple level, it's just looking out for changes. And then applying those changes to Kubernetes has its own copy of the configuration, which is held in a etcd database. So we're essentially going from the Git domain as our single source of truth and pushing that up to the Kubernetes etcd. It's a little bit more. I do not want to see other stuff. Sorry, other stuff flashing off the screen, but you're probably not seeing that, so it's just worrying me. Yeah, it's a little more complicated because we have to deal with the specific syntax of the Kubernetes files and the kind of details of how Kubernetes defaults certain settings and things like that. So.
How do you manage? How do you manage? Yeah, how do you manage that?
Well, the full details you really have to go through the code, but it's I'm just trying to say it's more complicated than it sounds to take those updates. But that's the kind of simple version. Just look across all the files in the Git repo. Anytime one of them changes, push it up to the Kubernetes server, and then Kubernetes has a lot of power in it to do those things like rolling updates of deployments, things like that. But yeah, that's at that level. That's what our synchronizer is doing.
What are there are tools in Kubernetes that allow you to do some of these things, right? What is it that you're bypassing? What have been some of the issues you've seen with some of the tools that you can use in Kubernetes to do similar things independent of Git?
Yeah, I as Alexis was saying, we're not claiming that this is earth-shaking. This is some tooling that we needed for our production system that has to run 24/7. That we develop across multiple different time zones and push updates out to all the time. So it's a classic kind of case that scratching an itch that we had this problem that we were bored making those little updates to the YAML files and pushing them out, and so we automated it.
Okay. So what are some of the major use cases for this that you're seeing?
I don't know, Stuart. Do you want to jump in at that point?
Sure. So, as Brian says, for us, this started with wanting to do less work, which is a good use case in itself. As a product manager, I want the engineers to be focused on building features. I don't want them to be spending their time doing deployments manually every day. But certainly, when you think about the benefits of automation and the gain in reliability, it sets you off down a path where you start to think about what else we're gaining here. And I think one of the things that we can observe is that there are benefits to security in the way that we have implemented this. The two components that you see on the diagram here, the automator and the synchronizer, are part of one agent that we run inside the Kubernetes cluster itself. And what that means is the access to the cluster, the credentials needed, and access to the API endpoints for driving the cluster never need to leave the cluster itself. If you think about a conventional CI pipeline pushing new packages freshly built from the CI pipeline into the cluster, the CI system has to have a copy of the credentials for the cluster, and it has to have direct access to the cluster's API endpoint, the control endpoint for the cluster, which certainly in things like regulated environments, be they for financial services or healthcare or any of those things, those are typically the challenges that have impeded those types of organizations from implementing automation into production environments, because the CI system is typically in a lower security zone or context, because that's an area where the developers have to get access to it. Where you have a component that doesn't leak those credentials back down into that lower context, where it's only needing to read from an image repository and read from a separate Git repository to describe the applications, it's much easier to put boundaries down at each stage and avoid leaking credentials across those boundaries. So you can build a really nice separate set of credentials and really separate the concerns for each of the security context for each component in your automation pipeline.
You also got a full audit trail there.
Right.
Again, for those people concerned about control of their environment. And if anyone does manage to bypass these processes and make a change directly on the cluster, which they shouldn't really be doing, the synchronizer will just overwrite that straight away. It'll recognize that as a difference from the Git repo and sync it back up again, and you'll be back as you were before.
So does that encompass then the security being baked in to some extent?
The way I see this is very much as you say, Alex. Security is baked in. If you trust Kubernetes, then you should trust the deployment synchronizer because it's deployed within Kubernetes in order to act as an agent on behalf of your application to stay in sync with Git and to alert you when there are differences, which means that you can inherit all the goodness from Kubernetes in terms of roles-based access control and other security and authentication to have a completely secure CI/CD pipeline, as opposed to a CI-driven model where your CI tool is outside of the system and is pushing changes into the cluster, which means that authentication has to be done through a potentially quite complex workflow that could break or cross organizational boundaries or create other kinds of issues, as Stuart described. Also, as Brian pointed out, because you're Git backed, you have a full audit trail. One of the major use cases that we see for this, in addition to security, is customers passing compliance. We actually have real customers who, to our delight, have passed SARbox compliance and would also get through HIPAA or PCI using this technique, because if you work in this way, you can see exactly who deployed what when, and you can prevent people from deploying things when you don't want them to. And that's very, very useful for people.
Okay, so Kubernetes is, its value is in its orchestration engine, managing containers. It allows for for very complex microservices to be developed. You have, but in itself, because Kubernetes is so interconnected, that you open up a lot of security runtime issues with it, and there's lots of security matters that start to surface, such as if you're running into multiple clouds, for example, right? And if you're in multiple clouds, it may be on your own environment, it may be on a cloud service, running your own installation, it may be using a management platform from one of the services itself. How far does this security story go with what you're discussing here in GitOps when in context with Kubernetes?
So let me try and answer that, and then maybe Brian or Stuart might want to jump in. I mean, you mentioned multiple clouds. I think that the concept of running multiple Kubernetes clusters on different clouds at the same time as part of a single app remains a little bit of a dream for the architects of this world. In practice, we're seeing people running apps that are limited to one location or bridging between an enterprise and a cloud is the other case that we see. But you do have the desire of companies and individuals to move between clouds and to know they can have an infrastructure that can be safely deployed in several places. And I think, bringing security and deployment with your cluster is a good way to do that, as opposed to having to set up a different pipeline wherever you go. So that is a way in which I think the answer to your question is yes. But I'm not sure if I'd go into more detail than that.
Okay. Going back to GitOps itself and its distinction as, and you do distinguish it from CI, and I'm curious on why you're making such a clear distinction in that, because a lot of people will associate what you're doing as CI and CD to some extent. What is the essence of that distinction that you really want to help illustrate for people?
Well, I think go on, Brian. No, you go first.
I fundamentally, the difference is that what you've got in your CI pipeline is source code building an application, building container images which are going to run. And what you've got in the configuration side is things like size of processes, size of memory, numbers of replicas, failover strategy. Those operational concerns which don't appear in the source code, and which Kubernetes gives you great flexibility to take the same image and run it at very different scale. So yeah, the very simple thing is what we on this picture, if you like, what's in the CI pipeline is source code. It's being assembled or compiled or whatever's necessary in that pipeline into the image that will run. And what's in the config side, the GitOps, the operational side of it is the configuration of how your system runs in your production cluster.
You guys talk about continuous experimentation as an alternative kind of viewpoint. What does that mean to you guys?
Well, that goes back to the velocity case. So we had 3 use cases which were security, compliance, and I think velocity was what we opened the podcast with. People want to get a phased transition. I've read this many times in the industry talking about continuous delivery. You gain confidence in your cluster and your app when you shift from having 1 or 2 brittle releases a week or worse to having as many as you like per day in your team. Your team will, hold their heads high, look out into the world with clear eyes, because they don't fear changes to their system, because they know they'll be able to roll them back. And they become much more used to making small incremental changes more or less all day long. to experiment with all kinds of things. This is something people have started to write about. This is where the industry is now going. That business wants to ask questions about, customer revenue streams and customer experiences really all day long, and expects the development team to respond instantly to that. And I think, if anything, we're helping people to get to that point with this new tooling. And as you can see from the diagram, going back to your question about, CI, I think that, it's what is the outcome of the process? It's experimentation. The fact the CI piece is somewhat incidental. You could be doing GitOps for months and months and months, even if you never made changes to your underlying code and never rebuilt your containers, because you're constantly fiddling around with the declarative configuration of the system. So this is operations as configuration rather than configuration as code. That's kind of a shift in emphasis towards the ability to operate at will at high velocity.
Okay, so let's go into some specifics a little bit. You have been managing Kubernetes on AWS for 2 years or so. Tell us about that. Tell us about that journey that you've been on with that, and how you've been using GitOps to manage Kubernetes on AWS.
Brian.
Like I said, we built a lot of this automation. So if you like, the journey that we've been on is from a much more manual style of editing the config files. I think we always put the config in Git because I should maybe stress that Weaveworks as a company has no ops team. It has an engineering team, and the engineering team also operates the production environment. So that makes us pretty motivated to automate things and try to not get paged in the middle of the night. So let's see, the 2-year journey, we set out to automate things as much as possible. We used tooling, including Terraform and Ansible. We started out, I think, Kubernetes 1.3, something like that. So done a fair number of Kubernetes upgrades, and the Kubernetes team does a fantastic job of making that work, and that you can upgrade from one version to the next. We always had the config in Git, but we didn't automate syncing it up. So we would edit the config and then kubectl apply, or kube control if you prefer the orthodox pronunciation. Let's see. I guess I don't have a really detailed story.
I'm not looking for, not too much of a detailed story. I'm really trying to understand, how how this illustrates how you develop this end-to-end pipeline, how you wired it directly into your clusters, and how that really encompasses, every step in the build, deploy, manage, and monitor lifecycle. So I'm trying to get an understanding of that, of the pipeline that you have and how it applies to AWS.
And we've always had a CI pipeline where we most of our systems are written in Go. So we compile the Go code. We run a battery of tests on it, and then if all the tests pass, we create an image. So that the beginning of the pipeline, those pipelines have been in place from before we were running Kubernetes. Setting up the cluster, that was quite a big learning experience. Back 2 years ago, we didn't know so much about Kubernetes, and neither did anyone else, I think. So setting it up, learning, certain practices, like we carve up the system by namespaces. Namespace is a way you can carve up your Kubernetes deployment. And then we map each namespace into a different directory in the Git repo. These are all kind of practices, and we've written about that. There's a lot of blogs. If you look at our Weaveworks blog, a lot of the individual experiences have been written up. But the key points of automation, I would say, syncing up config changes. So when you change one of those Kubernetes YAML files, or maybe even introduce a new one. We have dozens of microservices running in our production environment, and so it's relatively common to add a new one. So that automated syncing was put in, I don't know, somewhere around a year ago. And then the next step was automating putting a new image in. So I don't know if I can illustrate that easily. Let's go back to the config. We changed the port a few minutes ago, but the image. Let's take a look at that line that I've highlighted. So that is the output of the build for this demo. I'm building it on Google Container Registry. And every time I change my source code, essentially to deploy that image, I'm going to want to edit that number, that big hex number. So automating that was the next big addition to our pipeline that we can automatically get those numbers updated. That's if we choose to go straight from the CI pipeline straight into the deployment pipeline.
Okay. So one of the things that I get from listening to you and kind of in the review of the different blog posts I read, and I'm looking at one of your posts now actually, is that you have really put a lot of emphasis. I mean, obviously, I think one of the themes here is like, GitHub is what was I going to say? It's really what Git is what makes the delivery pipeline work, right? And from that, you've created a new tool, Flux, that enables GitOps deployment and natively understands how to manage deployments on Kubernetes. You guys call Flux a tool that automates the staging and release of containers to Kubernetes, as well as services, deployments, network policies, and even ACO routing rules. So Flux is the glue that maps all the relationship between the code, right?
Yeah.
It can be seen. You guys call it a learner. It also, can also, as a leaner, Kubernetes native alternatives to Spinnaker. Perhaps you could talk about that in the context of where we are today with GitOps a little bit.
So, let me take that. The Spinnaker is a wonderful tool which was created by Netflix to do the same kind of thing that Brian was describing. You've got lots of clusters in lots of places. You're making changes all the time, rolling out new microservices, and you want to make sure that it's done in a way that you can roll back. You can have deployment policies like blue, green, and canary, and you can automate or you be manual. You can have different workflows and all of the goodness, all through declarative config. But it was designed for an era of primarily VMs, and it's quite a complex project because there's so many different things you can do with it. We implemented deployment as as an orchestration extension to Kubernetes that lives inside Kubernetes and uses something called the operator pattern. And then, as Brian pointed out earlier, it understands all of Kubernetes idiosyncrasies, quirks, objects, verbs, APIs, so that you can deploy the things that Kubernetes wants you to deploy, which turns out to be a lot of different kinds of things related in weird, quirky, and wonderful ways. So in that sense, you could see this as a Spinnaker-like, but for Kubernetes and things like it. Does that answer your question, Alex?
I'm trying to understand that distinction. I'm trying to understand it perhaps in the context of the synchronization itself that you guys are talking a lot about.
Right. So Spinnaker and Flux, which is the open source project that drives this deployment synchronizer in the picture, in our case, have quite a bit in common in that, they're trying to build a relationship between the desired state of the whole system in Git and the observed running state in the cluster. Okay, so that's the bit that's similar to that between the two tools. Both tools are different from using CI to push changes into the cluster,
right,
which creates a direct relationship between the CI pipeline and the cluster without having Git in between. So actually, the way we integrate with CI is you can use any CI tool to update your images in Git. We integrate directly between the cluster and Git using this desired state, observed state parity driven by the synchronizer, which is driving conversions. It's a form of orchestration. Where Spinnaker and Flux are different is in terms of Spinnaker understands, if you look at the Spinnaker documents, it's very clear. It's primarily designed to handle groups of VMs on Amazon inside security VPCs and with a load balancer in front, which is the primary kind of deployment atom for a service on Amazon Web Services. Within Kubernetes, which is kind of a container cloud, if you will, you need to understand things like, what are they called? Deployments, services, daemon sets, to name three things. Do we still have replica sets? There's like a whole bunch of different objects
yeah.
that you need to understand. None of these are VMs, and they all behave differently. So that's the difference, Alex.
Mm-hmm. And so in CI, you had, in a CI environment, in a CI environment, you guys talk about Git as the design center, right? I'm trying to understand kind of what you guys mean by that. I'm
No. It's not the design center. It's the desired state.
It's the desired state. Okay.
Yeah. So it's the state that you fall back to if you have a disaster recovery situation.
Well, you guys say in the GitOps pipeline model, Git is the design center. It plays the central role of source of truth of everything in the system, right? That's how you guys describe it.
Yeah, I think that what is in Git is the desired state of the system, and everything puts Git at the center of the universe.
Okay, exactly. So what are you recommending to people now? What are you recommending to people? I mean, I get, I understand this concept of, of using developer tools. You've developed your own set of diff tools, right? That allow people to be able to kind of see the differences that are happening, inside their cluster, for example.
Mm-hmm.
What is it that then you expect customers to be able to do, or just anyone be able to do? What is it that, how do people get started? What are some of the ways that you really want to help people really adopt this GitOps methodology?
So, I mean, I think, we've gone into a lot of deep ends of the swimming pool on today's podcast. And what's great about this is that the payoff is so simple. Okay, you can forget about pretty much every single thing that we've said on the call, apart from the fact that once you set up your pipeline, you really can update your applications and operate them through GitHub or Git without using your own choice of CI. It doesn't matter which. It's very easy to switch around. We use Circle. Other people use Travis. Other people use Jenkins. It doesn't make any difference because all they're doing is pushing images into the repo, and everything else is driven by changes in Git. So it makes it super simple for a new developer to join your team and be rolling out production microservices on day one, which is frankly amazing. Secondly, when you look at people's desire to adopt something like Kubernetes, they're typically talking about improving developer velocity. But what's the point of doing that if you're using a traditional CI tool? If you do deployment using CI, what you do is you write scripts which are implemented as jobs by the CI tool. Those jobs then run and they try and push changes of code and of assets, build assets into your running system, which is a perfectly respectable way to do things. That's the traditional config as code approach. Everything gets built together and then shoved into the cluster by scripts. If that goes wrong, you're not in a state that you can recover from necessarily. You're in a world of having lots of different scripts maintained by different teams, which is the classic kind of script sprawl scenario, which is why having scripts that as a design center is famously unsustainable over time. So you forget about all of that. You can drop all that complexity and fear, and just move to a much cleaner world where you just make changes in Git. And then what you find is people don't panic when they do a deployment anymore. I mean, we have customers who used to do deployments using a traditional, Jenkins direct to Kubernetes, and it would take 30 minutes to do a deployment, and everybody in the team would stop and hold their breath while the deployment happened. And if it blew up, they'd all go, oh no, it's blown up again. We got to go back to the beginning. Where are we? What state are we even in? And now they found that once they switched to this approach, they could still use Jenkins, but what it's doing is putting images into the repo. And the rest is handled through Git, synchronizing with the cluster. And then they found that it was instantaneous deployment. It could always roll back. It didn't go wrong. It had predictable results. And it was much more controllable. And suddenly, people stopped having to down tools and wait while the deployment happened. They could have deployments while other people carried on working. The developers said that they stopped having to worry about deployments, and it freed up brain time, valuable brain time, to do things like, machine learning or some other business logic thing.
Right.
Customer happy. So that they stopped worrying about deployment, and they started to do more deployments because they didn't care anymore. They didn't see them as risky anymore.
Right.
And now you go to a few deployments a week that are brittle to as many as you like, as often as you like, and as small as you like, all day long, and everybody is super fucking happy. Forgive my language.
I'll forgive you this time. So internally, you guys use Docker containers and Quay.io for your image repository, and your Weave Cloud product works with any container repo, Docker Hub, GCR, and so on. When people are kind of thinking about their own internal kind of use of a pipeline, GitOps as you guys describe it, where do you recommend them to start? I mean, you guys have used these tools. I mean, are there any thoughts that you guys have on how people can just get started with this and what tools they might consider?
I would probably recommend using GitHub.
Yep, that makes sense.
You could certainly use Weave Cloud because it gets you started very quickly. GitOps is a pattern, and I've actually written down in my most recent blog post high velocity CI/CD for Kubernetes.
Right.
A few other examples of patterns just to emphasize this point. And also, I spoke about it with the Google product manager on Kubernetes, William Dennis, at KubeCon in Austin, about some different examples. And Kelsey spoke about the pattern too in his keynote. So there's several different ways to skin the cat, so to speak. But Weave Cloud is a great way to get started if you want an out-of-the-box experience. You can use any builder, any container repo. For example, we've found people to be successful with Google Container Builder and Google's container repo deploying straight to GKE. That's a great combination because you minimize the number of services you have to sign up for. But go ahead and use CloudBees for Enterprise Jenkins and private GitHub or GitLab, and you'll be just as happy. We've got examples that we've talked about with GitLab used for the repo and for the build as well. So there's just so many different ways to do this. I'd say probably the easiest ones are the combination of GitHub and Google Cloud, GitLab with Weave Cloud, and Jenkins and your own container repo for people who are in the world of kind of enterprise Java guys.
So I want to summarize where we are. So you guys say, pretty much what we're saying here, and I've read this in one of your more recent posts, is Git is the source of truth, correct?
Correct.
For the code plus all the config and the associated stack, correct?
That's right. Declare all the things. If it's not declarative, it's not described, it can't be observed, and it can't be automated.
Okay. So I'm looking at again. you talk about pull requests, and that's kind of, I think, a key thing here. There's a GitOps pipeline that is triggered by pull requests and orchestrated by the CD tooling. In your case, you're using Flux. So CI and contained repos play a supporting role.
So there what we're doing is we're talking about not only configuration as code, but operations as configuration.
Okay. And then containers, obviously, that are the unit of deployment for immutability. And you guys say that GitOps is similar to platform as a service, but you push containers and declarative config, not code. And any architecture that supports containers may benefit from end-to-end automated pipelines. And as we all well know, containers are pretty much can be used across, any environment now.
Right, but we're saying that your build asset should be built into immutable containers, but your config should be mutable and can be independently changed.
Okay.
So this is not quite the same as your traditional view of immutable infrastructure.
Okay. So we could discuss this another time, but then this gets into kind of issues around observability, right? And, and control, and how you monitor all the things kind of, in these different environments, using
Right.
this.
So if you declare all the things, you must be able to observe all the things. Otherwise, you can't automate.
Right.
So observability is a precondition of success.
Mm-hmm.
And that's pretty exciting because, as you know, observability is a hot topic of today in the fast-moving world of the new stack and other places like KubeCon and Twitter and places where cutting-edge developers are talking about exciting things. And what we found is that the right answer to how to operate your system has to include observability for cloud-native apps. And it needs to be thought about early on and baked into pretty much everything that you do. And you're right, it is a whole topic in itself, and there are some really interesting discussions to be had around just that. But just to get down to the nuts and bolts and the basics, we talked about diff tools earlier. Those are firing when you observe a difference between the desired state and the observed state. You're monitoring for that.
Well, this has really been a lot of fun. Thank you all for joining us for this live stream today. We'll also be posting this as a podcast. I want to thank the Weaveworks team for putting up with us. We had a bit of a false start in our last effort to do this a few weeks ago, but I really find this a fascinating topic and look forward to discussing it more because there's so many other topics that it provides relevance for, such as observability, which is another topic to discuss another time. So, Alexis, Brian, who else do we have here? Stuart, great. Well, thank you guys, and we will come back again soon for more discussions. Thanks again, and we'll talk to you soon.
Thank you.
Thank you. Bye.
Bye.
Bye.